Hello, my name is Marco De Angelis and I am part of the Bio-Home project, building material for affordable housing made from bio-based and recycled resources. Today we are going to talk about wood and about the modifications that are necessary to confer to the wood new properties. Welcome to my presentation. Wood has guided the human evolution in every step, serving as a material to produce objects and build houses. It serves as a fuel, enabling us to prepare meals and to produce light. In ancient times, the human beings learned how to use the different wood species depending on their properties, and they learned how to use the different part of a tree depending on the final use. Let's give a look to some examples. For example, yew wood was used for the production of the English longbow that played a crucial role in England's military strength. The yew wood, and in particular the high compressive strength of the hardwood and the high flexibility of the sapwood, made so that an English archer could shoot an arrow more than 300 meters away. Another example brings us to the city of Venice. Venice stands on a lagoon. The Venetians, in order to build strong foundation for their city, inserted thousands of sessile oak and large poles into the soil. They were very aware of the high strength and durability of these two species. Of course, also the lack of oxygen into the moist soil of the lagoon plays a crucial role in the conservation of wood, but we will talk about this in another video. Except for few wood species, wood is very sensitive to moisture, and this involves low dimensional stability, low resistance to biodeterioration and rot fungi. In addition, it can be attacked from insects and marine borers. During recent history, when wood was needed for an application in severe conditions, such as in presence of water or in contact with soil, the best option was to use hardwood tropical species, which are naturally very durable. A less expensive alternative was to treat the not durable species with chemicals such as CCA or creosote. However, the use of these chemicals would represent a risk for the safety of people, animals and for the environment, both during service life and after disposal. With the increased awareness and the restriction by law of the use of environmental non-friendly chemicals on one side, and the growing awareness regarding the use of rare tropical species on the other, it has been necessary in recent times to develop and introduce new wood modification technologies. A wood modification is a comprehensive term to describe a method that alters the biological, mechanical, physical, and chemical properties of wood, depending on their desired final use. Wood modifications can be ascribed to two main categories. Active modification, which result in a change in the chemical nature of the wood, and passive modifications, which result in a change in properties of the wood, but without altering its chemistry. Within the active modifications, we can list thermal modifications and chemical modifications. A chemical modification involves the reaction of a reagent with the cell wall polymers hydroxyl group, with the formation of a chemical bond with one OH group or a cross-linking between two. The wood, so modified, has a lower equilibrium moisture content, and therefore it is harder for rot fungi to find the necessary moisture to survive. In addition, there is a physical blocking of the cell wall micropores, and therefore is more difficult for the fungi to enter the cell lumen. Up to present days, the most prominent processes that involve a chemical modification of the cell wall to a full or partial degree are the acetylation and furfurilation, and both have been scaled up today to an industrial level. Other minor processes are a modification with a thermosetting resin, modification with DMDHEU, the indurite process, the key wood process, and impregnation with vinyl monomers. A thermal modification is made by applying heat on wood, generally between 180 and 260 degrees. It implies a chemical change in the nature of the material. In fact, it results in a chemical degradation of the lignin, the cellulose, and the hemicellulose. In the case of thermohydro and thermohydromechanical modification, the heat is used in combination with water and force. The type of thermal treatment can change depending on many variabilities, such as time and temperature of the treatment, treatment atmosphere, closed versus open system, wood species, wet and dry system, size of the wood, and the use of a catalyst. The main positive outcomes of a thermal treatments are enhanced dimensional stability, reduced water absorption, decreased weight, darkening, and enhanced durability. But on the other hand, we observe a reduction in the wood mechanical properties and a tendency to cracks. Within the passive modification, we can list the impregnation with chemicals of the cell wall. The main purpose of this modification is to enhance the wood durability. This is a very broad area that still attracts a lot of interest. Usually the impregnation is made by diffusion of a soluble material into the cell wall and by applying high pressure. Normally, a subsequent treatment is necessary to render the material insoluble. It is important to underline that the high pressure is used only to facilitate the impregnation of larger wood samples, while the impregnation of the cell wall is controlled only by diffusion. To be effective, it is essential that the chemicals is not leachable during service condition and must be non-toxic. Another type of wood modification is the wood densification. During the last decades, the wood densification has been studied as a process to increase the density in low-density species. It is made by applying a compressive force on the wood in order to obtain a permanent deformation of the wood cells. As a result, we obtain a higher surface abrasion resistance, higher hardness and strength. There are two kinds of wood densification. The first one, the bulk densification, that focuses on the densification of all the cells of the sawn timber. The second one, the surface densification, that focuses only on the surface cells layer. The densification is achieved by softening the wood using steam. After that, a compressive force is applied on the wood using heated rollers.